limit 9 minus x over the square root of x minus 3. X approaches 9. What do we do first? To determine this limit, what is our first step? Always?
Plug it in.
Thank you. The numerator goes where?
0.
Very good. The denominator goes where?
0.
Good. So there is hope. It's one of the indeterminate cases, 0 over 0. So the usual ones in this class will be 0 over 0 or infinity over infinity. So you can say, but wait a minute, how come that 0 over 0 is not 1? It's not 1. Do not conclude. You cannot conclude if you get an indeterminate case. That's what they're called, indeterminate. Who knows? We have no clue. And look what it was. You cannot say that 0 over 0 is 1. So be careful with that. Good. So then which one is the factor that must go away for sure?
Would it be x minus 3?
But I plugged in 9.
Oh.
X minus 9.
Of course. If I plug in 9, so let's go back here for a second just to make sure that what I'm saying here. Oh. It's right above my nose, right with the page, right? If I plug in negative 2, I cannot say that the factor is x plus 5. If I plug in 3, I cannot say that the factor is x minus 7. If I plug in 3, the factor has to be x minus 3. If I plug in negative 2, the factor is x plus 2. If I plug in negative 4, the factor is x plus 4. Is that clear? Good. So the factor is x minus 9. So I expect somehow to get rid of x minus 9 from the top and the denominator. Okay. So I will continue with a square this time. So the equal symbol and square. So you know where it goes. Okay, I have to copy the limit. Do not drop the limit operator. Okay. I realize that the numerator is twisted. So I'm going to factor out negative 1. Immediately. And then I look at the denominator and I don't really know what to do with it. But I do know a process that allows me to multiply and divide by the same number, which means that is 1. If I multiply and divide by 3, I don't change anything. But it will allow me to simplify this function eventually. What is that process I'm talking about? Anyone? What is it called? When we multiply and divide by the same quantity to simplify, especially when we have a radical expression. Rationalizing, in this case, the denominator. And that is why we reviewed on the first day of classes, let me see if I have it handy, this, and this, and this. Good. So what do I need to multiply and divide by to make this happen? Anyone? How do we rationalize the denominator? What is the quantity we need to rationalize the denominator?
Would we multiply it by the square root of x to turn it into just x eventually?
No, because when I multiply by this, I will still have to distribute to negative 3 and it will not go away. Anyone remembers this? We use the conjugate. There are two terms. If it's one term, I would say, yeah. If I only have this, I will only need to multiply by the square root of x. But I don't have just one term, I have two terms. So what is the conjugate of the square root of x minus 3?
Would it be plus 3?
Correct. So both of them have to take. Very good. And this is 1. We're not changing the expression. So now the numerator, do not drop the limit operator. So the negative in front, I have x minus 9. I have the square root of x plus 3. And now let's see what we have in the denominator. Can anyone give us the denominator?
X minus 9.
Very good, because we are using a plus b times a minus b, which is a squared minus b squared. Well done. Who said so?
It was me.
Thank you. Thank you. And we'll see what happens. Exactly what we expected to happen. Thank you, Alex. So, what did you expect to happen? What was our expectation? To get rid of which factor?
X minus 9.
That's it. Are we getting rid of it? Gladly. Now, can anyone give us the limit? And that this is the answer, and we are dropping the limit operator now because we are finding the limit. So what is the answer?
Negative square root of x plus 3.
We are applying the limit, and we drop the limit operator.
It's 6.
With minus. Very good. The limit operator is applied. When x approaches 9, the square root of 9 is 3. 3 plus 3 is 6. With minus in front, negative 6. Is this okay, everyone?
Yep, I got it. I saw where I went wrong.
No worries. So finally we get to 36. So limit as x approaches 3 from the right of the square root of x squared minus 9. Good. What is the first step whenever we are asked to find a limit algebraically?
Just plug it in.
Let's plug it in. So 3 from the right with numbers higher than 3, but 3 basically. What do I get?
0.
That's it. Done. Okay. So pretty much that's all I wanted to talk about so far. Now we are ready to finalize this section. Let me go back to what we just wrote here. So the algebraic limits and the limit laws, we're going to see more later, but now I would like to address continuity. I couldn't hear you. Can you speak up?
For number 36, that's a definite does not exist.
0 is a number. Every time I give a number, any number, the limit exists.
Okay.
0 is a number. Infinity, negative infinity are not numbers. D and E is not a number. But 0? Very acceptable. Is that okay? Continuity. Okay. Here's a function. I'm going to graph a function. And you will tell me whether this function is continuous. I started here. I did not raise my marker off the paper at any point in time, just to put the arrows and say it continues forever. Is this a continuous function?
Yes.
Of course.
Yeah.
Continuous. What do we mean by not continuous? Look at this one. Go ahead.
So any of them where it's like they have the different rules throughout and there would be gaps. So
Excellent.
Like the step-
Piecewise defined function. Very good. Awesome. Jump discontinuity. Jump discontinuity. Okay, here's another type of discontinuity, and you'll tell me what it is. That's not the function. What type of discontinuity is this?
I want to say whole discontinuity.
Infinite. Infinite discontinuity. And there is one more. This one, or same thing, or this one. They are both the same. They have the same name, and they have the same property. Okay, I'm assuming you, and I'm not going to ask you the name of this. I will tell you what it is. So both these two cases are called removable discontinuity. So if this is A, and this is A right here, what is the property of these two? Which we cannot write it here. It does not have, this one does not have this property, and this one does not. So here it is. The limit from f of x, of course this is f of x, as x approaches a from the left, equals the limit of f of x as x approaches a from the right, but it does not equal, what do you think? Wild guess. Any volunteer? So the left
The
and
limit
right.
of f of x as it approaches a's from both sides.
So the limit from a from the left and from the right are both, they both exist and they're equal, but they do not equal what? Look at the graphs. The graphs will tell you. So these two are equal to each other. They exist, but they do not equal what?
A.
F of A.
Excellent. Who said that?
I think me and Blake said the same thing.
No, you got it. I just said A.
So that's what it is. F of A, indeed. This is a removable discontinuity. Okay, continuity at a point. Very important definition. So how do I say that the function is continuous at that point? I will say that the limit of f of x as x approaches a from the left equals the limit of f of x as x approaches a from the right, and it must equal what?
A.
Careful.
F of A.
Very good. This is continuity at a point. Exactly what the removable does not have. So limit from the left and from the right are the same, and they must equal the function value at that point. Perfect. Okay. So let's finish up with anything you'd like to look at, including graphs if you want, from 37 through 75. That's all I had to say about 1.2. Okay, till you choose something, I'm going to choose 56. On 115, and that is g of x. So you know why I tortured you with piecewise defined functions. We're asked, is this function continuous? At 4. Before we address that, I just want to mention a theorem. Polynomial functions are continuous everywhere. Because they are defined everywhere, they are smooth, continuous functions everywhere. The rest, rational, etc., are continuous on their domain. Rational, radical, etc., etc. So this is a polynomial function, linear function, this is a polynomial function. So both pieces are continuous. But the question is, for this problem, continuous at x equals 4? Yes or no? What do you think? Anyone will give it a shot?
No,
No. Why?
because x never equals 4.
Because f of 4 is undefined. Very good. Thank you. Who said that? Was it Jackson?
Lake.
Thank you. Very good. That's the reason why. I don't have to write the continuity at the point, the definition of continuity at the point. I don't care if these two limits exist. If this one doesn't even exist, what's the point in wasting my time? No. Because the equal symbol is nowhere to be found. Function is not is not defined at 4. How can it be continuous at 4? Very good. Awesome. Anything else you would like to pick? What if we look at 74? On page 115. We have the copy shop charges 0.08 per copy for quantities up to and including 100 copies. For quantities above, so the function is given to us. So the price is calculated as 0.08x if x is less than or equal to 100, and is 0.06x for x greater than 100. We're asked to find the limit. We're not asked to graph, but we're asked to find the limit as x approaches 100 from the left, and limit as x approaches 100 from the right, and the limit from both sides, from p of x. Okay? Ready? So the limit from the left of 100, I do not drop the limit operator. I know I sound like a broken record, but I will see it on your quizzes and work and tests, and I just want to make sure that you understand. We drop the limit operator at the very final step when we apply it. So I drop the limit operator in the next step because I applied this process to this function. Once I apply the process to this function, I get the final answer and the limit operator disappears. Not till the last step, till I apply it and then it goes away. Okay, ready? From which function?
It has to be the first, right?
Absolutely. Thank you, Rita. Good. And how much is the answer? Zainab, what is the answer for this? Are you there? Okay.
Yeah, I am.
Good. What is the answer?
I'm not really sure.
Any? Right. 100 times 0.08 is 8. Good. Obviously, for the other one, we have limit as x approaches 100 from the right. From which function? I know it's silly to
Still
ask.
0.08.
Right. Silly to ask. And the answer is?
0.6 or 0.8?
So when I multiply 0.08 by 100, I move the decimal point 2 spots to the right, so I get 8. When I multiply 0.06 by 100, I move the decimal point 2 to the right, and I get?
Well, I'm saying because x is approaching 100, but if x is 100, it's 0.08. So wouldn't it be 0.08x in the parentheses? And it would be the same thing as from the left?
But
You're
0...
talking about everything above 100.
Yeah.
If you're approaching to 100, you're still talking about everything that's above it.
It's
okay.
It's 100 from the right. I have to
I see.
I have to use this function. So what is the limit from either side?
Does not exist since they're different.
Very good. What type of discontinuity is this?
Is it jump?
Thank you very much. Jump discontinuity. On one side we have 8,